How to draw inference line for panel beams? Steps. Step number 1. Draw the inference line for the girder. Draw IL, I use IL as inference line. For girder. Okay, so I'm sure you can do that. So, and you know the difference between girder and floor beam. Girder is the bottom beam. Place this inference line, the one that you just draw for girder, below top beam. Top beam means slant. But it's easier for you to understand. When I say top beam, you understand what I mean. Girder is bottom beam. And then once you place it, project panel points from top beam onto the inference line. Later you will see how to do it. Now it's not clear for you. Later we will go through each step.
Is that still part of step 2?
Yes, that's part of step 2. Step 3. Connect projected point. So now we start doing it. For that example. That example is this one. A A, B, C, D, F. A, G. So basically these are the panel points. So panel points, panel points. So panel points A, B, C, D.
And then the cantilever at the end?
Yes, according to the drawing, this is the example from the textbook, the one that we just saw. So, and then this is G, this is E. So you have the panel points, we have the girder, and then you see the part at the end is a cantilever. Yes, exactly the drawing from the textbook. So A, B, C, D, E. F is a roller. G is also a, F is a pincer. The dimensions are 10, 10, 10, 10. Okay, so this is example 6.13. Example 6.13 from the textbook. We are going to use this professional method to draw the inference line for panel CD. Draw inference line for panel CD. First step, we consider a point between C and D. I'm going to, it doesn't matter which point, but for the sake of simplification, I'm going to choose a point exactly in the middle of CD, just for simplification of the calculation. So I consider this point, and because it is exactly in the middle, it is 5, 5. So we are going to draw the inference line for this point. We say, let's call it point O. For shear force, for point O, and then we are going to use girder. This is the first step. Draw the inference line for the girder, the bottom beam. Any question for the first step? It says draw the inference line for the girder, okay, which is the bottom beam. And because the question is asking for shear force for panel CD, we need to consider a point between C and D. It doesn't matter where, eventually you get the same result. But for the sake of simplification and saving time, I'm just using a point exactly in the middle to save the time for calculation. So now, how to draw the influence line for girder? I just use the blue color one. This is the girder. Remember our practice so far? Forget about today's lesson. Consider the previous session. You have this blue color beam. You want to draw the shear force at point O. What was the method? You cut it at point O, Mueller method. Consider the
Unit deflection.
consider the sign convention, remove the constraint, replace it with a proper joint, which is a shear hinge here, and then apply a unit displacement, etc. So I just write the final answer because you know it. You know the process. So this is the beam. Point. I draw it exactly below. This is point A. This is point G. This is point O. And this is point F. Any question? Remember, this is the girder. I'm drawing the inference line for the girder as the first step. So A, G, O, and F. And I draw the inference line like this. Clement, do you remember this? When you place a shear hinge at point O. And that time, We said that this is x, this is y. We said x plus y is 1. We said at two sides of the shear hinge we must have the same slope. So it means that x divided by this distance from O to F, which is 15, must be equal to y divided by distance between G and O, which is again 15. This is what we did before to find x and y. And then from here you can find x and y. X is 0.5. X and y together are 0.5. So we are done with the inference line for the girder. Just take a note because I'm going to draw the second part. So we are done with the first step. Any question? We drew the inference line for the bottom beam, which is a girder. You can include these steps on your crib sheet if you forget. It's fine. Second step. Now, place this inference line below the top beam. Okay, we already placed it below the top beam. The top beam is the one in red. The top beam is the slab in red color. Okay, we place it exactly. Place it exactly. So it means this is A, this is A. So it must be in scale to avoid confusion. Project the panel points from top beam onto the inference line. Project the panel points. The panel points are point A. So when you project it, it means you just draw a line vertically, and then how much is the ordinate of this inference line? The height of inference line is professionally called ordinate. So far we have been saying height. Now I'm using this terminology, ordinate. So if you project point, the amount of the ordinate of inference line is 0.33. Because you already draw this inference line. So this one from here to here is 0.33. Why? Because this is 0.5, this is 0.5. You have all these dimensions. So you have this angle, you have this angle, you have this dimension, so you can find. It's just geometry. Did you understand? It's just geometry. Okay, next panel point. Which one is the next panel point, Clement?
B.
Yes. Project it onto the inference line. 0. Okay. Next panel point, Peter. After A and B, what is the next panel point?
C.
Yes. Project it. It means you just come down. Do you agree this is the projection? When we say project it, it means draw a vertical line until you just intersect the inference line. And then find the ordinate of this point. Using the geometry, whatever, the ordinate for this point is 0.33. Clement, did you understand? This one is 0.33. This is the ordinate. And from C, we just come down. I'm just using yellow color for them, for the projected point. Mason, next panel point. After A, B, and C, what is the next panel point? D, right? So you just project it, come down. When you come down, it becomes point D. It comes.
Or sorry, 0.33?
Yeah, but my drawing is not very accurate. I mean, it's not to this scale. So when you come down, it is somewhere here. and Braden said 0.33. So when I draw a vertical line, it comes here. So I'll give you time to understand. Any question? What is the next panel point, Adrian?
E.
Yes. So, do you agree if I draw a vertical line from E, I just go to the F, and then the ordinate is 0? You agree?
Yes.
Okay. It is not difficult, but you must be focused. Okay. Project them. Okay, we are done with step 2. We are done with step 2. Any questions so far? Step 3, connect the projected point. Okay, the yellow points, just connect them by a straight line. Connect them by a straight line. The red diagram is the final answer. That's it. Or maybe I should use another color for the final answer. I just redraw it with green. This is the final answer. We just connect them by a straight line. And then all the geometries are here. If you want to calculate these values, they are all there. So this is the professional method. So the answer must be the same as the textbook. Look at this green line. This is exactly what you see on the textbook. But the textbook is using plotting method. These steps could be confusing, but if you just focus, then they are not difficult. Okay, done. So for the next example, for all of the panel beams, these 3 steps are required, and then you can draw. So in this way, you don't need actually, if you compare the time, this is more time saving. So if you solve this using the plotting method, the time required is more than this. That's it. Okay, now we solve one more, because we still have time, good. We solve one more problem using the same method to practice more. But that problem is not in the textbook, it's just from me. So I am going to erase this part, okay? Next problem. We have a pin support here. We have a roller support here. This point is F, G, H. Try to draw it to the scale, because later if it is not to the scale, then yeah, it's confusing. This is I, this is J. And then the dimensions are 2A, 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 A. 2A, 2A, 2A. So this is the girder. And then I'm going to use what color? Orange. We have I panel here. I tried to draw it in a larger size. H. I panel here. And from here, this is your beam from here to here. So the top beam is drawn in green. Point A, B, C, D, E. This is A and 2A. Okay. So you can see between C and D we don't have the top beam, or we don't have slab, which is fine. This is the design. So I intentionally bring this example here because you can see we don't necessarily need to have slab between C and D, and also the top beam doesn't necessarily need to be geometric in the same line with the girder. You can see we have extra distance here, we have extra distance here. So they don't need to be in the same shape, right? The green one is the top beam, which is the slab. The bottom one is the girder, and the orange color are just I panel, cross section of the floor beam. The question is asking to draw the vertical, to draw the inference line. Inference line for the reaction. Draw inference line for reaction at support J of girder. This is the question. Support J is here. So for a better understanding, I just show these dimensions, just for better understanding. So you know the dimensions. Okay. Later I may not be able to draw it accurately to the scale, but these are all 2A, 2A, 2A. This is A, this is A. So now we are going to draw the inference line for reaction, the vertical reaction at point J for the girder. Any questions so far? So we go through these steps. Step number 1. What is the first step, Mason?
So we need to draw the influence line for the, is that yellow?
Yes, the inference line for the yellow one, which is the bottom one, which is the girder. What is the constraint or variable? Reaction at point J. So forget about today's lesson, go back to the previous session. You just want to draw the inference line for this thing, for RJ. Using your knowledge from previous class. Okay, I draw it here. I put a solution. Solution. Where is the unit load moving, Adrian? Is the unit load moving on the girder or moving on the slab? Slab, right? For reality. Yeah, you drive your car on the slab of the bridge. So the unit load moves from A to B, from B to C, and then it doesn't move from C to D, and then from D to E. Okay. I'm just moving slowly because I want to make sure you understand. So now I'm going to draw the inference line for RJ, and I use orange color. So this is point J. I intentionally put the support here, support. And this is 1. Do you agree? This is the inference line, as Mason said. This is the inference line for RJ for the girder. We just lift it upward 1 unit. Is it correct? This is F, this is J. I just write girder so that. Next step. So we are done with the first step. We are done with the first step. Second step, place that inference line below below your top beam. Okay, we already placed it right below the green beam. The green beam is the top beam. It's already there. And then project the panel points from the top beam onto the inference line. Again, I'm going to use yellow color. I'm going to project the panel point from A because the unit load moves from A. So when I project it, the value is 0 here. Do you agree? Okay, 0. Remember, later you have to connect these yellow points together. The second panel point, which one is the second panel point, Mason?
B.
Yes. So you just draw a vertical line. The ordinate of the inference line, which is the height of the inference line, you already have this, this geometrical dimension. The ordinate is 2/7. Clement, why? Why 2/7?
Because it's 2A out of 7.
This is 2A, right? The total length is how many? 7A. So this is 2A, the total is 7, this is 1, so this is 2/7. Just compatibility equation. Okay? Okay. Emmy, which one is the next panel point?
C.
Okay, project it. So you just draw a vertical line and then find the ordinate. How much is the ordinate? Emmy, how much is the ordinate for this point? Clement, you can help.
4/7.
Yes. in the same way. Clement, next panel point.
It's 607.
Yeah, which is D, right?
Yeah.
Draw a vertical line. Next panel point, Clement.
It's just one on.
No, wait, panel point.
Oh, sorry, E.
Yes.
And
So
0.
we are done. The yellow points are the projected points. So we are done with the second step. Now I'm going to move to next step, which is the third, but I give you time. Any questions so far? So, no question. No question? No. Basically, if you focus, it's not difficult, but you need to focus. Okay, now, we are going to move to next step. Connect them. You just move it. The first point is this one, okay. They are a straight line, but the line may break. I don't know if the slope of this line and this line is the same. There is no reason to be the same, unless you show it with the ordinates, etc. So this is panel point C. This is panel point D. Do I need to connect them? There is nothing here. Your unit load doesn't move here. So you don't need to draw inference line for this section. So for this section, I leave it just blank. And I continue from point D to the last point, which is E. The green line is the answer. The green line. Here is, so let's say this is your, for example, exam. This is the final answer. This is 2/7. And from 2/7, you go to 4. 4/7. That's it. My drawing is not to the scale. That's it. So here is just empty. And of course you should, you should include more data. For example, this is 2A, this kind of thing. You should include more data. This is point B, so this is from here to here is 2A. The next point is C, 2A. And then this one is 2A, we leave it blank. And this one is 2A. To avoid any confusion, we can have point F. And this is point F. Point J is here. Just, so be careful about the dimensions. That's it. So this is the, you can use the plotting tabular data. Means you place a unit load here, you place a unit load here, and then you move, but it is more time consuming. Another thing is that, do we have a floor beam at point F? We don't have, because the question says. So be careful about. Maybe another question: place a I shape in here, a panel point. So be careful about these details.